This is set up as like a research and education center, but the focus is on natural resources. So it's on conservation and management of natural resources. I'll just have a few slides there, and then I'm going to show some results of some lionfish work that I thought would be of interest. But as you know, here in the nature, and I'm sure most of you know this is a unique part of the coast of Florida and coast of the United States. It's one of the least developed shorelines left in North America. And its economy is uniquely tied to natural resources. Southwick Associates said that 13% of all jobs in this area are directly tied to natural resources. The statewide average is only 1% of those jobs are tied to natural resources. So management of quality, fish and wildlife habitat is going to be essential to the region with our valuable commercial and recreational fisheries and those kind of things. So the university has a long history of work here in the Nature Coast. Leslie Sturmer has been here in Cedar Key for over 20 years working with the hard clam aquaculture industry. You know that the industry here in Cedar Key is valued at over $30 million in clam aquaculture. There's been extensive fisheries, forestry, wildlife work from the University of Florida going on over here for a lot of years. It's the closest coastline to Gainesville, and it's a place where a lot of our aquatic-oriented faculty flock to do research. This is also a unique area, in a little town of Cedar Key, only 700 people, but there's a lot of science capacity here. And with our state and federal agency partners, there's a lot of capability. We've got 3 refuges with the Lower Swanee, the Cedar Keys, and the Crystal River National Wildlife Refuge, all here within easy distance. And we work really closely with the refuge staff. And then the Fish and Wildlife Commission, FWC, has one of their 7 fisheries independent monitoring labs right here in Cedar Key. And we work really closely with them. A lot of their staff are pursuing graduate degrees with us, with the university. We do contract work with Taj, who's going to speak in a little while. We do contract work with them as far as side scan sonar. And so we have a really close collaboration with them and have for a long time. They also produce what's over an 18-year data set of long-term fish monitoring data here in Cedar Key. So that's also an excellent opportunity to leverage those data on proposals in the region, because we have long-term monitoring data of the region here for the inshore food web at least, and increasing monitoring of offshore. Okay, so the station is, if you come in on State Road 24 and just don't turn, you'll end up in the parking lot of the biological station. So it used to be the Gulfside Motel, and the university bought it essentially at first to have increased access out to Seahorse Key Marine Lab, which we also operate, Seahorse Key Marine Lab. But after acquiring the property, we decided to build the facility to build this research and education center, basically as a biological station. And then we want to improve our research, our teaching, and our extension programs. And we work really closely with Florida Sea Grant. Savannah Berry, who's got the earphones on over there and doing some of our recording today with Rebecca, is here at the biological station as a regional specialized extension agent. So her job is to communicate science out to the public in this region. And we've got a couple of research professors as well. So I was just going to show you. So here's the biological station. We've the ground level here, and feel free to stop by there after the meeting today. The ground level there is where the wet lab's going to be. There's no air conditioned space on that ground level, and FEMA regulations made us go 19 feet up before you could have any construction of air conditioned space. The 3rd floor, the very top floor right now, is completely unfinished. That will end up being a classroom, but there's nothing up there right now. And we're working to develop the wet lab and what's going to be a public education and aquarium on this storefront. This is a unique biological station. We visited a bunch of them over the last few years, but this station is located within the historic district of Cedar Key, right downtown, and it gets a lot of people that walk by it. So it's a huge opportunity to communicate science out to the public. And we're really proud. Mindy Allen with the development office has been working really closely with Levy County and Tisha Whitehurst, who's here today, to develop this space that will be for public education. And this is going to be in that public education aquarium area, and it's a depiction. Raymond Rawls, who helped with the Florida Museum of Natural History, developed this. And so this is going to be an area where we'll have an aquarium that has native fish in it. There'll be a touch tank. We'll be able to highlight things about the clam industry and about the ecological work going on in this region. So right now there's nothing in there except a bunch of machines working on making a glossy floor, but our plan is to develop this further. We worked really closely with Levy County to try to have this be a real education center for citizens in the county. So, and we're working with them on one of the NOAA Restore proposals, which would finish the 3rd floor and create a space up there for public use and this public education area. And then the wet lab, which is on the behind that glass front end area, that we're working to develop right now, which will be a working wet lab for clam aquaculture research on oyster reef restoration, seagrass ecology, those kinds of things. It'll be a very modular lab that people can use for a variety of different studies. So that's kind of our plan for the biological station. We just opened this building in September, so it's definitely still under development, but going well, I think. So feel free to stop by after the end of today. Also wanted to mention with Keith Calusa, I'm really proud of the work that we were able to do with Tom Ankerson and working with Hernando County on a science plan for Hernando County. And I think that gives the county, and it's a good example to show, what are the priorities for future work in natural resources and fish and wildlife, and how would you go about achieving those objectives. And so we're going to get that up on our site, Keith, and we'll be able to share a link to that science plan. Okay, so now I want to show a little bit of data because I haven't done very much reef stuff. You know me, most of my work has been freshwater. I kind of feel like I came out of a swamp and now I'm talking into an artificial reef workshop. But I want to talk about some colleagues of mine and a study that we did. This is funded by FWC, and it's an interesting study that we just completed this past summer, or this past year. Holden Harris is a PhD student in fishery aquatic sciences, and Will Patterson is also a faculty in fisheries and aquatic sciences. And Will would normally be here. He does a lot of reef fish ecology work, but he's at an International Otolith Symposium in Taiwan right now. So he wasn't able to make it. But I want to show a little bit of Holden's data and talk a bit about this lionfish project. And again, this was FWC, and also Holden received some funding from NSF as well for his PhD. I'll show that. All right, now this is a USGS thing that I borrowed, but this is a chronology of the lionfish invasion. And you can see the year is coming up here, okay? So, and it'll start over in a second. But you can see that the lionfish started in the early 90s. They were detected down in Southeast Florida and then expanded up the Atlantic coast pretty rapidly, and then throughout the Caribbean, and then got in the Gulf. They didn't get in the Gulf really in any numbers until 2010. So this is a fairly recent invasion. As I know many of you are aware, Keith is nodding like, yeah, there's the lionfish invasion again. You probably spend a lot of your time worried about that. But you can see that it's really they're throughout the Gulf, and then the northern Gulf are some of the highest densities of lionfish anywhere. Now, one interesting thing, and I've got a project under consideration to look at this, is that there's actually fairly low reports of lionfish in the Nature Coast region, and the reefs out here like Bill's Reef, we don't see very many. You don't see very many lionfish on your reefs. I heard a rumor of a lionfish being caught off the dock here in Cedar Key. Denny Boyles told me that, but I didn't see it. And I heard there's a barge out in about 30 feet of water that a diver reported seeing one last year. You saw it, Tosh? You have? Okay. So there's a few, but not like over near Destin, where some of these artificial reefs over there will have 200 or 300 lionfish on them, just tons and tons of lionfish. And we're definitely not seeing that here. And I don't know, I suspect it's a larval transport. They have over a 40-day larval cycle, and it may be that the larvae just aren't recruiting into this area. That's an interesting topic, though, because this area might serve as kind of a control / pre-invasion type area to look at what the fish community and the rest of the community looks like before an intensive invasion. But I'll talk about Holden's research here, and this is one of his chapters of his dissertation. So as you know, the lionfish are poisonous. They've got a venom in their fins, and and they don't take hook and line very well. And so the removal methods has pretty much been scuba spearfishing has been the main way that these lionfish are removed. And what we wanted to look at in this project is just how effective are those removal efforts? You know, what fraction of the lionfish do you see and not see, and are you able to remove when you do one of these dives on these reefs? And how's that influenced by artificial versus natural reef? Are you more effective on artificial or natural reef? And so this was working up in the northern Gulf of Mexico on reefs that Will Patterson's lab had been working on for a long time. And so we wanted to look at this, and I'll just show a couple of slides of his data. So it's up in the Panhandle, okay? And we did 6 artificial and 6 natural reefs. I'll give you a bit of the, and his artificial reef sites were several types, okay? There's this type A, these triangle metal reefs. There's the reef, a couple of different reef ball types. And Will's previous work had showed that these artificial reefs had some of the highest lionfish densities ever recorded throughout the invaded range. Some of these could have 200 to 300 lionfish present on at the very highest numbers. So very high density lionfish abundance. The natural reefs were ledges of boulders and some live bottom and usually a half to about 2 meters of relief. We looked for those sites that we used as natural reef sites and had 6 of those. Okay, and then they went in and divers went in and removed these lionfish by spearing. Okay, and this video of lionfish are fairly easy to spear, and of course you're limited by how deep divers can go and how long they can stay down there. But once you're down there, we wanted to see, well, just how efficient is this at removing these lionfish from these sites? Okay, so artificial reefs. So basically what we did is we did a depletion sample. So we would go to each of these sites 3 times, usually in successive days. So we'd go one day, then we'd go back the next day and the next day. We made the assumption that between days the site was closed. In other words, there was no immigration coming in to the reef over that 1-day period. Which we looked at that assumption, which I think was a pretty reasonable assumption, because the recolonization rates on these reefs were fairly slow. And so we would go do one day, do a depletion, and then we'd go the next day, and then go a 3rd day, and then sometimes a 4th day, depending on in some of the natural reefs, depending on what kind of depletion we were getting. Okay. And so this is just a Leslie depletion model where you have catch per effort on the y-axis, so lionfish speared per minute, say, and you have cumulative catch over the successive visits to the reef. Okay, and what you're trying to estimate is what would the cumulative catch be if you caught them all, if every one of them was caught, right? And the slope of that is the catchability coefficient, which is the fraction of that stock that's reduced per unit effort. Okay, so a little linear regression for you. So okay, so here's the results. I just have a couple of result slides, and I'll be happy to take any questions. This was really good news for these removals, is that it looks like these divers are really efficient at removing lionfish, and actually on average on the artificial reef sites, about 83% of the lionfish are removed on the first pass. Okay, so they get, and if you work with fisheries like I do, that's unheard of, really, because we have almost no sampling gear that is that efficient at removing animals from an area. So 83% removal on the first pass on average is really impressive. And by the time they do 3 passes, you essentially removed about 99% of the animals. There's almost no lionfish left by the time you do three passes. So that was really interesting. A really interesting finding is that in one dive on an artificial reef, you can remove the majority of the lionfish present. Not all of them, you don't get them all, but you've removed most of them. And this is the artificial reefs are the ART, and the natural reefs are here. And this is the catchability. So this is the fraction of the lionfish removed per, think of this as per dive, per dive. Okay, so on the artificial reefs, in the range of 84 to 89% of the lionfish are removed per dive to the site. Now it was lower. There was less effective removals on the natural reefs. Okay, so the artificial reefs is actually 88% was the average catchability, and the natural reefs. Okay, thanks. The natural reefs 56%. So the removals were not as effective on these natural reefs. And I think there may have been more. First of all, the natural reefs were somewhat bigger in area than the confined artificial reefs. And there may have been more hiding places for those lionfish to get up into ledges and that kind of thing and not be observed. So they're only removing about half the lionfish per dive on the natural reefs and about 88% on the artificial reefs. Okay, so, and this just shows a cumulative removal that you got almost all the lionfish by the time you did 3 dives or especially 4 dives. So I think his results so far are encouraging. To me, they're encouraging, showing that we can achieve a local depletion, a substantial local depletion using scuba diving in the zone that's shallow enough for scuba diving. And Holden's work with Will and us that follow up on this is looking at the recolonization rates, and there's some on that poster over there. And the recolonization rates were actually of adults, colonization of adults back on these reefs were actually much slower than I expected. And so what it showed is that you could substantially reduce lionfish on a reef and keep it down by diving it every few months, that kind of thing. So I think that with this lionfish invasion, what it points to in my mind is that it's possible to achieve a localized depletion and keep that depletion down with continued removal efforts. So that's the results of this so far, and I'll be glad to take any questions. And thanks again for giving me the time. Yes.
This wasn't like the main purpose of the project, but did you see differences in population or clusters, like more lionfish focused on artificial reefs?
Yeah. Yeah, and Will's work has showed that really strongly that there's much higher lionfish densities on the artificial reefs than on the natural reefs by an order of magnitude. It's substantially higher. So I don't know why that is. I don't know what it is about the artificial reefs that they like, but Will's done a lot of work here, and he's actually shown some unique things about how red snapper use reefs, and if there's a lot of lionfish on a reef, the red snapper actually are further distance from the reef than if there's not a lot of lionfish on a reef, so they separate themselves. Yeah, that's an interesting topic. Marty.
Mike, I was talking to some folks from Puerto Rico doing their coral surveys, and they said they're noticing a lot more predation on lionfish have been in half and things like that.
Yep.
What are your observations?
Well, so Will's shop, Will would be the best one to answer this, but his shop's done a lot of DNA barcoding of food habits so far and has not found a lot of predation of lionfish by grouper snappers so far in the Gulf of Mexico. His lab did, however, document using DNA barcoding cannibalism. And it looks like what we're seeing in the lionfish invasion is that the densities of lionfish have peaked and are starting to go down. And I'm thinking that there's some density dependent cannibalism that's starting to happen. But so far, there's not a lot. I haven't seen a lot of evidence for our native fish eating lionfish. What about the FWC folks? Have y'all seen evidence for that in the food habit studies?
I mean, you hear local things.
Yep.
As far as, I was spearing a lionfish and I was like, which is right off my spear or something like that. But I don't think it's like enough to be doing anything.
Mm-hmm.
What about eels?
I haven't heard anything about eels.
Mm-mm. I haven't. No. All right. Yes.
So if you have a couple of artificial reefs out there that are you're not finding lionfish now, are there any recommendations to help keep them off the reef?
I mean, so the reefs are colonized by the larvae usually, right? They settle out and get on these reefs, and then they live there and grow up. And so to prevent larvae colonization of the reef is going to be really difficult. In my mind, for what we've learned so far is that the lionfish management is going to be to identify places where and this is part of what Holden's working on for his dissertation, where is it feasible to do removals? so it's shallow enough you can dive, it's close enough to shore that it's easy to get to, and when can you do removals at a regular thing to keep them down and maybe mitigate the impacts locally? I think that's the best, our best option is to identify those spots and do it that way. Any comments from the FWC on that? I mean, that's.
Yeah, I think the challenge is that you're trying to build a market
Yep.
for the fish as well. So inherent in that, your commercial divers or divers that are harvesting, sell to market are constantly going to want to visit the high density locations. So to create an incentive for divers to revisit priority sites for removal to keep those levels low, I mean, that is the challenge. And that's where our FPC Lionfish program is trying to come up with other incentives to get people to revisit, adopt reefs, help keep these numbers down. And it might be when you return on your second or third time, you might not have as many lionfish to sell at market.
Yeah.
Than if you go to a totally different site. So I think
that's the challenge. Yeah, that's part of what Holden's interested in too. By the way, the boats that we were going out on are the captains that were doing commercial lionfish harvest, and they had great information and actually shared a lot of great data with Holden from their removals. So, yeah, Bill.
Do you think targeting source sites might help buffer the big bed? Like just Gulf County or
I think one of the next.
Hillsborough County and try to keep
I think one of the next topics that would be really good to look at is to talk to some oceanographers about the larval transport mechanisms and identifying where those sources are. The problem with this is the deep water refuge. There's so many lionfish that are below 100 feet. We don't know what fraction. That's another question. But a lot of the population is below the area that it's easily accessible for divers, and that may be the majority of the source. My understanding from folks in the Keys now is that on the shallow reefs you don't see many lionfish because the removals have been so intense.
What's the season of the larval transport?
It's spring, summer. So they spawn all summer. So yep. So it's
that offshore.
It's all summer.
Transporting inshore like the gag larvae are coming in the late winter, early spring.
Yeah, I mean, you would have better knowledge about that than the seasonal dynamics there, but yeah. So it is all summer, so it's a long window of larval transport occurring. Keith.
I'm glad you found this population. It's the same thing on the non-biased. For the past 4 years, but the follow-up to that is that the store questions they ask are how are you going to manage lionfish that we compared to retail? And our response was, well, we don't have that in this county, but if you have data to show that great to reference that.
Yeah, I can share you. This is USGS information, but I can share that with you. Absolutely.
All right, we're gonna have to
Okay.
set it off, sorry.
Yeah, I'll be around, so I'm happy to answer any other questions. Thank you.
Yeah.